So my dear students, a question comes in our mind that what is the need of spherical polar coordinate systems? If we're already having rectangular coordinate systems, then what was the need for designing this coordinate system? Okay, so let's going towards the answer. But before that, it should be very clear to you what we mean by rectangular coordinate system first of all. Okay. Now, in case of rectangular coordinate system, we are having x-axis, y-axis, and z-axis. And thereby we are having three planes: xy axis, xy plane; yz axis, yz plane; xz axis, xz plane. Now these coordinate systems helps us for finding the position of the object. Maybe it here, maybe your position of the object is at here. How? Just finding what is the value of x. Just finding what is the value of, just finding if the object is here, just finding what is x, y and z. If we know x, y, z values, we can fix the position of the object. This is our rectangular coordinate systems where we take the help of the three axes which are mutually perpendicular to each other. Now coming here, this is spherical coordinate systems. In spherical coordinate systems, you know very well that again we are having the three elements: rho, theta, and phi. You know, this rho, I'm interested for finding position of the particle which is at here. Then first of all, I draw a semi-sphere, and then I mark some origin. Okay. Then I'll choose xyz axis. Then this was my point P. Now it is on the semi-sphere. Then I'll join. Now this is the point P on the semi-sphere. So I join O to P. Okay, now this vector, OP vector, you may call this vector as R vector, you may call it R vector, or you may call it the rho vector. So this is our the first element, which is R vector or rho vector. Now second is angle, zenith angle, angle phi. This is the angle which OP, this is OP vector, it makes with the z-axis, positive z-axis. Okay, like this is our z-axis. This angle is called angle phi. Then the phi can have, as R and rho, it can have, R vector or rho vector can have any value 0 to infinity, depending upon your point is here or at this distance or at this distance. So it is increasing. So it can have value 0 to infinity. And phi, the zenith angle, can have any value 0 to pi. Why pi? because like this is positive z-axis and this is our negative z-axis. This is negative z-axis. So if the point is here, if it is here, the phi angle will increase. If the point is here, it will further increase. So the phi can go from here to here, means 0 to pi. Now the third angle is azimuthal angle. Azimuthal angle. This angle is phi. So what is this angle first of all? Now this was our point P. From this point P, you draw a perpendicular. You draw a perpendicular on XO y plane. Okay, so this is perpendicular on this plane, XOY plane. Then I mark this point as point M. Then OM vector, it makes an angle phi with x-axis. So this phi can have any value. This phi can have any value from 0 to like up to here. 0 to 2 pi. So phi is azimuthal angle, can have value 0 to increasing 90 degree, and it is increasing 90 degree, 180 degree, okay, and then go on increasing, ultimately it reaches to 2 pi. So there are three elements: rho vector, that means the radius vector, angle theta, zenith angle 0 to pi, azimuthal angle which varies from 0 to 2 pi. So with these three elements we can specify the position of any point or any particle in the space. Likewise, as we fix the position with the help of Cartesian coordinates. Okay, so the rectangular coordinate systems can be quite difficult to use in certain situations. What are those situations? Some of the most common situations when Cartesian coordinates are difficult to employ involve those in which circular, cylindrical or spherical symmetry is present. Okay, it is difficult there to employ the Cartesian coordinate systems. For some situations, it is often more convenient to use spherical coordinate systems to illustrate how you describe the location of a point on the surface of the earth. We generally use latitude and longitude. There is a spherical coordinate system, very similar to the generally accepted one, with radial coordinates like the radius of earth, the polar coordinates like latitude, azimuthal coordinate like longitude. Spherical coordinates are generally easier when you are dealing with something that is more or less spherical. As one might imagine, this includes balls and planes, black holes, planetary orbits, field around the points like gravitational, electrical and more. This is the reason why we use spherical polar coordinate systems. Thank you.